Hi everyone, today I am going to explain about the concept of expectation in probability theory and stochastic process. The concepts that are going to be covered are introduction, definition of expectations, expected value of continuous random variable, expected value of discrete random variable, properties of expectation, and an example question. Now, let us go into the introduction. Expectation provides the average or mean value that a random variable would produce over a large number of trials. It is in the key link between probability theory and real world applications because it gives a single representative value for a distribution. Means expectation provides both average, either average or mean value. It is a random variable would produce about large number of trials. This links between probability of real world applications too. Now, this means if an experiment represented by random variable x is repeated many times, the average outcome will tend towards the expected value. Mathematical expectation or expected value. Definition: the mathematical expectation or expected value of a random variable x. The mathematical expectation or expected value of a random variable x is the mean or average value of its probability distribution. It represents the long-term average outcome if an experiment is repeated many times. Means mathematical expectation is represents long-term value of average outcome if an experiment is repeated many times. It is denoted by x bar or e of x. Mathematically, it is a weighted average of all possible values that a random variable can take, where the weights are probabilities, are their probabilities. Mathematically, like if any some weighted averages or anything like taken, then these possible values are random variables and can take where the weights are their own probabilities. Expected value of a continuous random variable. If x is a continuous random variable with a valid probability density function fx of a, then expectation of x is equals to minus infinity to infinity x into fx of x into dx. Here x is a value of random variable, fx of x is the probability density function and nothing but small pdf or x. The integral calculates the average value, consider all possible outcomes. Here integration is used to calculate all the possible outcomes of the expectation. Expected value of a discrete random variable. If x is a discrete random variable with possible values x1, x2, x3 and so on xn and corresponding probabilities p of x1, p of x2 and so on p of xn, then expectation of x equals to summation I is equals to 1 to n xi into p of xi. Here xi is the ith possible value of the variable and p of xi is the probability of xi. N can be finite or infinite. Here discrete value, in case of discrete value we add the probabilities and multiply each probability with its corresponding value and then we sum up all the probabilities. So we used here summation. Next, properties of expectation. Property 1, expectation of a constant. If a is a constant, then expectation of a constant is a constant. Like we have considered a constant as a, e of a is equals to a. Proof: in case of discrete, expectation of a constant e of a is equals to summation. As we know the summation, as we know for discrete case, summation x into xi into p of xi. So here summation x into a into p of x is equals to a, some a into summation of p of x. So as we know summation of p of x is 1, the sum of probabilities is equals to 1, a into 1 is equals to 1. In case of continuous, expectation of a is equals to minus infinity to infinity a into fx of x, fx into dx. a into integral minus infinity to infinity fx dx is considered as 1 as its area over integration. So a into 1 is equals to a. Property 2 is multiplying a random variable by a constant. If a is a constant, then e of ax is a into e of x. Here x is a variable like x, y, so on. Proof. In discrete case, expectation a of x is equals to summation of a of x into p of x. A into summation x into p of x. As we know, summation of x into p of x is considered as expectation. So a into e of x as given in the property. Now in continuous case, expectation of ax is equals to integral minus infinity to infinity ax into fx dx. Here a into integral minus infinity to infinity x into fx dx is equals to a into e of x, as integral minus infinity to infinity x into fx dx is considered as expectation of x. It is in case of continuous continuous expectation. Now property 3, expectation of a linear function. If a comma b are constants, e of ax plus b is equals to a into e of x plus b. Here a into e of x is like previous property, similar to its previous property, plus a constant b. Now proof. Discrete case, expectation of ax plus b is equals to summation of ax plus b into p of x. Now let us split for both variables. So a into summation of x into p of x plus b into summation of p of x is equals to, as we know, summation of x into p of x is expectation e of x plus summation of p of x, as we know the total probability, sum of total probabilities is equals to 1. So a into expectation of x plus b of 1. So a into e of x plus b as given in the property. Now in continuous case, expectation of ax plus b is equals to minus infinity to infinity ax plus b into fx of fx dx is equals to, let us take a as constant, so it is out of the integration, integral minus infinity to infinity x into f of x dx plus b into integral minus infinity to infinity f of x dx. Here we have split the integration to both values and multiplied f of x to both ax and b. Here, as we know, integral minus infinity to infinity x into f of x is expectation of x plus integral minus infinity to infinity fx of fx dx is considered as area over integration, so it is considered as 1. So a into e of expectation plus b of 1 is equals to a into e of x plus b. Next property. Property 4, non-negative random variables. If capital X greater than or equals to 0 always, then expectation of x is also greater than or equals to 0. Proof. In discrete case, since x greater than or equals to 0 and p of x greater than or equals to 0, every term in summation of x into p of x is non-negative. So their sum is non-negative. Continuous. Since x is greater than or equals to 0, fx greater than or equals to 0, then integral minus infinity to infinity x into f of x dx is non-negative. Here this case shows that property 4, expectation of x is greater than or equals to 0. In discrete case, summation x into p of x is non-negative, so their sum is also non-negative. And in continuous case, whereas x greater than or equals to 0, as function of x is always greater than or equals to 0, as x greater than or equals to 0, so integration value is also will be non-negative. Next, property 5, inequality of absolute values. Expectation of x, mod of expectation of x less than or equals to expectation of mod of x. Proof, Jensen's inequality, or it is triangle inequality. In case of discrete, mod of e of x is equals to mod of x into p of x less than or equals to summation of mod x into p of x. Here we can write mod of summation of x into p of x as summation of mod of p of x. So as we know, summation of x into p of x is equals to e of x. Here in place of x we have mod of x, so we wrote as e of mod x. Next, in case of discontinuous, mod of e of x is equals to mod of minus infinity to infinity x into f of x dx less than or equals to integral minus infinity to infinity. Here we have considered mod is only for x, as it is only the variable present in the integration part. So integral minus infinity to infinity mod of x into f of x dx is equals to expectation of mod x, as similar as above. Now, as we know, the mod is considered for positive values and negative values. Mod is used to change negative values to positive values, right? Property 6, linearity for sum of functions. For two functions g1 of x and g2 of x, expectation of g1 of x plus g2 of x is equals to expectation of g1 of x plus expectation of g2 of x. We have splitted the expectation for both g1 of x and g2 of x. Proof, in discrete case, expectation of g1 of x plus g2 of x is equals to summation of g1 of x plus g2 of x into p of x is equals to summation of g1 of x into p of x plus summation of g2 of x into p of x. As we know, x into p of x is equals to e of x. Similarly, summation of g of x into p of x is also equals to expectation of g of x. So expectation of g1 of x plus expectation of g2 of x. Let us consider an example question. If capital X is a discrete random variable with probability mass function given as in table 3.1, find expectation of x, expectation of 2x plus 3, and expectation of x square, and expectation of 2x plus 1 whole square. Given x values are minus 2, minus 1, 0, 1, 2, and probability of x values are 1 by 5, 2 by 5, 1 by 10, 1 by 10 and 1 by 5. As we know, these expectations are similar to our properties. Now let us try to apply the properties. Let us try to solve this problem using properties, right? Expected value e of x. Formula, as we know, expectation of expectation e of x is equals to summation I is equals to 1 to n xi into p of xi. Substitute values of I. Now e of x is equals to minus 2 into 1 by 5. As we know, the first value x1 is x is minus 2 and corresponding probability is 1 by 5. So we have multiplied minus 2 into 1 by 5. Similarly, the value of minus 1 corresponding probability is 2 by 5. So we multiply minus 1 into 2 by 5. Similarly, 0 corresponding probability is 1 by 10. So 0 into 1 by 10. Next, for 1, its corresponding probability is 1 by 10 again. 1 into 1 by 10 plus for 2, for value of 2, the corresponding probability is 1 by 5. So 2 into 1 by 5. Now let us sum up all these, and we get expectation of x is equals to minus 3 by 10, which is nothing but minus 0.3. Next, expected value of e of 2x plus 3. As we know, the property expectation of ax plus b is equals to a into expectation of x plus b. And similarly, here we use the same property. Here expectation of 2x plus 3. As we compare with the property, the value of a is equals to 2 and the value of b here is 3. So 2 into expectation of x plus 3, nothing but a into expectation of x plus b. So as a value is 2 and b value is 3, similar to our property. We have previously calculated the expectation value e of x as minus 0.3. Now let us substitute the value of expectation here. 2 into expectation of x, nothing but expectation of x is equals to minus 0.3. 2 into minus 0.3 plus 3 is equals to minus 0.6 plus 3, which is nothing but 2.4, which is the value e of 2x plus 3 is equals to 2.4. To find e of x square, let g of x is equals to x square. Then expected value of e of x square. As we know, e of g of x is equals to summation of g of x into p of x is equals to I is equals to, let me choose this, I is equals to 1 to infinity xi square into p of xi. Now expectation of x square is equals to summation I is equals to 1 to n xi square into p of xi. Substitute the values. Expectation of x square is equals to minus 2 whole square into 1 by 5. As we know, the value of x is corresponding value of x is minus 2. So we have squared the value of minus 2 and we have multiplied with the corresponding probability 1 by 5. So minus 2 whole square into 1 by 5 plus minus 1 whole square into 2 by 5. Similarly, x value minus 1 and corresponding probability 2 by 5. So minus 1 whole square into 2 by 5 plus similarly 0 also 0 square into 1 by 10, as we wrote here, 0 square into 1 by 10 plus 1 into 1 square into 1 by 10 and 1 square into 1 by 10 plus value of x is 2 square into 1 by 5 and 2 square into 1 by 5. So we got 4 by 5 plus 2 by 5 plus 0 plus 1 by 10 plus 4 by 5. Total we sum up and we get as 21 by 10, which is equals to 2.1. Now the last part of the question, expected value e of 2x plus 1 whole square. Expand this 2x plus 1 whole square is equals to a plus b, similar to our a plus b whole square, a square plus b square plus 2ab. So 4x whole square plus 1 square is nothing but 1 plus 2 into 2x. So 4x square plus 4x plus 1 is the expanded form of 2x plus 1 whole square. Using linearity of expectations, expectation of 2x plus 1 whole square is equals to 4 into expectation of x square plus 4 into expectation of x plus 1. As we expanded the 2x plus 1 as 4x square plus 4x plus 1. So we have applied the value of the expectation for the corresponding values x square. So we got 4 into expectation of x square and 4 into expectation of x plus 1. As we have previously calculated the values of expectation of x square, e of x square and e of x, we got them as e of x square is equals to 2.1 and e of x is equals to minus 0.3. So we have substituted the values of 2.1 as 21 by 10 and minus 0.3 as minus 3 by 10 plus the the 1 as the above given. So 4 into 21 by 10 plus 4 into minus 3 by 10 plus 1. 84 by 10 minus 12 by 10 plus 1 is equals to 73 by 10 is nothing but equals to 7.3. So thank you.